All right, let's go ahead and take a couple more examples. These are going to be examples that are not necessarily that straightforward, uh, but yet they are. So let's take f of x is equal to 1 over x minus 1. Okay, so now we've got an inverse function here, and we kind of know what this looks like. We know that it's going to look like, if we just graph it out real quick, it's probably going to look like something like this. And that's about it. Okay, so we want to find the slope at any given point. All right, well, then just simply go through our steps. F prime of x is equal to the limit as delta x tends to 0 of f of x plus delta x. So that's 1 over x plus delta x minus 1 minus 1 over x minus 1 all over delta x. Okay, so that means we're going to have to go ahead and do some cleanup up top. So we're going to need to make the top look like each other. So let's see here. Well, we've got an x minus 1. We've got a that. Okay, so let's just multiply everything by x minus 1 and then all that junk over here as well. Okay, so we've got on the top, underneath, we're going to have x minus 1, x plus delta x minus 1. And then on the top here, we're going to have x minus 1 minus x plus delta x minus 1. All of that over delta x. Okay. So now, all I'm doing is playing with this part. I'm not going back yet. So I'm going to just drop this straight down and start cleaning it up. All right. So I've got, if I distribute that negative to each thing, then I've got x minus 1 minus x minus change of x plus 1 all over x minus 1 x plus delta x minus 1 over delta x. And now we can start shaving things down here. Got a negative 1 there, a positive 1 here, a negative x, positive x. So those things cancel out. And I am simply left with the limit as delta x tends to 0 of negative delta x over x, whoop, the other x minus 1 times quantity x plus delta x minus 1 all over delta x. And now for this, we can, since this is a fraction divided by a whole number, or a number anyway, this is the limit as delta x tends to 0. And this is going to be a negative delta x. We invert and multiply. This is going to come to the bottom. So it's delta x, x minus 1, and x plus delta x minus 1. So we have that is equal to delta x's cancel. That leaves me with negative 1 up top. So that equals negative 1, or the limit, as delta x tends to 0 of negative 1 over x minus 1, x plus delta x minus 1. And now we can just use direct substitution to solve this, because we have no quarrels making delta x 0, so that goes off to 0. And so I get f prime of x. If f of x is equal to 1 over x minus 1, f prime of x is equal to negative 1 over x minus 1 squared. And you'll see that we don't have any problems with the derivative unless x is equal to 1. So this is good. And this works. So this is the derivative of f, and this is defined for all reals not equal to 1. And so as long as we're not looking at, hey, what is the derivative of this and what is the slope of the tangent at 1, as long as we're not dealing with that, yeah, we can go ahead and say anything we want about the derivative. So there's the first example. The second example has to do with square roots. So we get f of x is equal to the square root of x plus 1. Okay, so now f prime of x is equal to what? Well, it's the limit as change of x tends to 0 of square root of x plus delta x plus 1 minus square root of x plus 1 all over change in x. Okay, so now we have to try to do something with this. So